This lecture is our introduction to the respiratory system. So the reason for having a respiratory system is gas exchange. All animals need oxygen, and all animals, and this includes us, need to get rid of carbon dioxide. The carbon dioxide is produced by the body. So we get this oxygen and we get rid of the carbon dioxide by way of diffusion out of the air into our bloodstream and out of our bloodstream into the air. But I'm going to give you a quick reminder about what diffusion is. It goes like this. All molecules in air and liquid. All molecules are in constant motion. And as a result, they collide. With each other. And as a result, they slowly spread out. Basically, from an area of high concentration, that is to say, an area where they are highly concentrated, to areas of lower concentration, that is to say, where they are in lower concentration, until they are slowly completely spread out evenly over a given area. And this is called moving down a concentration gradient. This is a term that we hear quite a bit about in physiology. So basically, things always move down a concentration gradient unless they are actively prevented from doing so. The way to think about this is, first of all, if you've ever been in a store where they're spraying perfume or something like that, you'll notice that it will be a very intense smell right near the perfume, but you'll still smell it a little bit further away, and even a little bit further away, there will be a little bit of perfume there. One way that I tend to like to think about it is this. All molecules are in motion. If they are in air or they are in liquid, they're bouncing around. And so think of them as being like super balls, those really bouncy balls, except these are super balls that have little motors in them, so they vibrate. So we have all of these little vibrating molecules of different sizes. They'll bounce at different rates, but they're all sitting there being super bouncy and doing vibrating all on their own. If you got a big box of those and you pour them down on the floor, they're not going to stay in that one place. They're not going to stay where they're highly concentrated. They're all bouncing, they're running into one another, they're colliding off of one another and ricocheting, And as a result, they are going to spread out all over the floor of your room unless there's actually a wall stopping them. And this is how molecules act. The molecules are in constant motion. They're vibrating a little bit unless it's absolute zero in temperature. So they're all vibrating a little bit, and that means they're going to bounce and they're going to spread out. And that then is what diffusion is. So things always move down a concentration gradient. So they always move down it. That is to say, from where they are in high concentration to where they are in low concentration. They always move down a concentration gradient unless basically they are actively prevented. Or I will say actively forced, because sometimes there are pumps and things like that to do otherwise. And this business of moving down a concentration gradient until spread out then is called diffusion. That's what diffusion is. And this is a passive process. That means, when I say passive process, what this means is that the organism doesn't have to do anything to make that happen. There is no energy expended on the part of the organism to make that happen. It just happens. If there were no organism there, diffusion can still take place. So, as I said, it's a passive process. The organism does not have to do anything to make that happen. Now, I am just going to briefly add that there is something you will run into from time to time called facilitated diffusion. And that then is basically diffusion that is made faster by carrier proteins. But that's just as a quick aside so that you will have heard this. Okay, so now let us get on to gas exchange then between the animal and its environment. So this gas exchange then is done through what is called a respiratory medium. The respiratory medium is basically the substance from which you are extracting the oxygen and into which you are putting in the CO2. So a respiratory medium can be air. That's what we extract oxygen from. Other animals, like fish, extract oxygen from water. But one way or another, you always have to have a respiratory medium. And I'm just going to say that air has much more oxygen in it than water does. So things are a little bit easier for us. And animals have what are called respiratory surfaces. And these then are where gas exchange takes place. So the respiratory surfaces then are really the reason for having a respiratory system. Everything else is devoted to getting the air, in our case, to our respiratory surfaces. So, as I said, respiratory surfaces are incredibly important. I'm just going to say as an aside, animals have many different respiratory surfaces. In us, they are buried in our lungs. Fish have gills with respiratory surfaces. Frogs have skin through which they can do gas exchange. So in the case of frogs, their skin is also a respiratory surface. Okay, so here's a really important thing to know. Respiratory surfaces must be moist in order to work. If they are not moist, there will be no gas exchange. You can maybe see how there's a problem here. Those respiratory surfaces deep in our lungs, for instance, must be moist in order to work. However, we lose moisture when we exhale. You can see this on any cold day. You breathe out and you wind up seeing some of that moisture condensing in the air. But whether you see it or not, we're losing moisture from our lungs, from our respiratory surfaces every time we exhale. And we are taking in much drier air. So what I'm getting at here is that our respiratory surfaces, then, which are very delicate deep in our lungs, the respiratory surfaces where gas exchange takes place, our respiratory surfaces must be protected. And the good news is that because our respiratory surfaces are buried so deep in our lungs, there are a lot of structures before the air gets that deep into our lungs that helps to condition the air so that it's okay for those delicate respiratory surfaces. So, basically, air that reaches our respiratory surfaces has been moistened. As you breathe in, whether you breathe in through your nose or through your mouth, that air goes past lots of moist surfaces in your nasal passages, in your mouth, in your throat, going down your trachea, and so on, but particularly in going around in your nasal passages. There are lots and lots of very vascular, moist tissues in there, and the result then is that the air that passes by all of those surfaces winds up being moistened before it gets down to the respiratory surfaces in your lungs. So the air has been moistened, and the air has been temperature adjusted. So on a cold day, it will have been warmed. If it's a very hot day, it might have been cooled. Again, you have that air passing by all of those surfaces in your nasal passages and the like, and it's picking, on a cold day, it's going to be picking up heat as it goes down. Remember, if the day is below freezing, that air could, in principle, freeze your lungs. You don't want that. They will definitely stop working then. So what you need to do then is actually warm that air up, and that happens by way of the kind of tortuous route that the air takes getting to your lungs. You would not want a direct passage to your lungs because the air would be too harsh. So as I said, the air has been both moistened and temperature adjusted on its way to your respiratory surfaces. So as I said, this happens because the air passes by the warm, moist tissues in your, that's an N, in your nose and mouth. Okay, now, there's a special thing that I want to bring up here, just very briefly, which are your turbinate bones. Okay. So the turbinate bones and the nasal conchae. Okay, when you were studying the skull, I hope you remember those little nasal conchae on the side of your nasal passage in your skull and the like. And we also have these rather peculiar lacy looking bones known as the turbinate bones. And they exist then basically in our nasal passages. And what they do is they increase surface area for the air to pass. So as air passes through, especially the nasal passages, the air is swirled. Basically, it's swirled, it moves around, it hits all of these moist surfaces, and basically it kind of takes its time getting where it's going, and as a result, this allows the air to become moistened and temperature adjusted. Because if this didn't happen, our lungs would cease to work. They would dry out, they would freeze. In extreme circumstances, you could wind up having them boil if you were standing too near a furnace. So as I said, you have to have ways of actually getting these things to be the right temperature, as well as moistened. And that then is what is really the point behind having turbinate bones and nasal conchae, but also just all of the kind of peculiar conducting passageways for air that we will talk about later. All of this contributes to making sure that the air is pretty friendly by the time it gets to your respiratory surfaces. And that's it for this lecture.